And welcome back to TikTok Math with Mr. Campbell and Miss Walton. Here we are to tell you about the wonderful new world of surface area. Now, we all know this is a cylinder, and you as an expert in your mathematical skills have been able to tell me the volume of the cylinder, in other words, how much space is on the inside, how much soup, how much food, how much liquid can it hold. However, now we want to look on the outside with that beautiful Campbell's Soup label right there and ask ourselves, if we were in charge of putting the label all the way around this can, how would we measure the area we would need? How would we measure the amount of paper we would need to cover that beautiful Campbell's Soup can right here? Now, interestingly enough, we have a dimension right here. The height of the can is 5.6 inches. And we also have a diameter across the base of the can. Now remember, the base is a circle, and there's a base down here, and there's another base up here. And we have that diameter, but, interestingly enough, you probably don't feel like there's much of a connection between this diameter and the distance all the way around. More on that later. If we were to take this can and just unfurl it, open it up, and look at it, we might see things from a slightly different perspective. There we go. We still have the circular base and the circular base, but look what's happened to the label. When you unwrap it all the way, it makes a perfect rectangle, which is a lot easier to think about measuring and evaluating than when we see it in its circular form. So those are the theoreticals. Surface area of a particular shape can be ascertained by paying attention to the details, and there's actually going to be a formula in a minute, but we just want you to understand that you've got to unwrap things sometimes to try to see them in the right context. That'll help you know how to use the numbers and therefore find the surface area. Ms. Walton?
All right, so sometimes when we are looking at different topics in math, for me it helps to look directly at the title and kind of rearrange it. So when we look at surface area, it's really just the area of surfaces, okay? So once we unraveled this soup can, we now have a surface, and a surface. And that's what we're gonna look at right here. So I've put a soup can or some other cylindrical object on this graph paper, and remembering that area is finding the area of each of these shapes. As you can see, we have this on graph paper, so we could find the area by counting all of these little squares up inside. Counting all the little squares up inside, which would be a little bit difficult if we were trying to count these circles, because if you look here, there's not full squares. Like, these would be easy to count all of the squares and we could get a number, but here it would be a little more difficult. So that's when a formula comes in handy, and I'm going to show you that right now. So we have a formula, and again, these are formulas that will be available to you and not required to memorize. They'll be on your formula charts. So we have a lateral surface area and a total surface area, and the formula is as follows. So we have the surface area equals 2 times pi times radius times height for the lateral surface area. And we have a total surface area that reads surface area equals 2 times pi times radius times height plus 2 times pi times radius squared. So I wanted to, if you notice here, this formula here, 2 pi RH, is the same as 2 pi RH. So the lateral surface area, when we're looking at the lateral surface area, that is going to be the label. So think lateral label. We have the label of our soup can. So I'm going to recognize here that our two unknown values are the radius and the height in order to find the lateral surface area. So we had those numbers. I'm going to go and grab them. 2.8 and 5.6. So 5.6 and 2.8. So that's our diameter and our height. So I'm going to fill those in here. So we have 5.6 as our height, and 2.8 is our diameter, but right here we know we need radius. So we're going to have to take that and divide it by 2. So half of 2.8 is 1.4. So once I substitute that into my formula, we'll have surface area equals 2 pi times the radius 1.4 times the height of 5.6. So that, once that gets plugged into our calculator, maybe, oh, there it goes. So we're going to go ahead and write in your calculator 2 times pi times your radius, which was 1.4, times your height, which was 5.6. And from there, we get 49.3 to the nearest tenth. 49.3. And so what we know here, we've now solved for this portion of our problem. So the only other thing that's missing, and maybe this looks familiar to you, right here I'm going to use, so we have this pi r squared. So pi r squared, hopefully from the volume unit you recognize that pi r squared is the area of a circle. And when we look at our soup can unraveled, we have 2 of them. So that's where our 2 comes in. So 2 times the area of a circle, because we have 2 of them. So what we can do is substitute the numbers that we already have. So again, we already did this here. So we can take this number and put it here, 49.3, plus, and then we just need to fill in what we don't know, 2 times pi times 1.4 squared. So going back to our calculator, what we can do is, since this is already saved here, I can just do this answer plus 2 times pi times 1.4 squared. And that will give us our 61.6 as our total surface area, meaning if we were trying to, so this lateral surface area is what would happen if we were just trying to find the lateral surface area of the label, whereas, I'm not in the camera, of the label, and for the total surface area, that would mean that we would want to also cover the 2 bases of the cylinder.